Hello, and welcome back to MA211. We want to start talking now about actually solving differential equations. And before we can do that, let's just take a second to remember the chain rule. Now, if y is a function of x, and I want to take the derivative of y squared with respect to x, remember that what we really have here is, let me get my pen out, I'm taking the derivative of f with respect to x, where f is, let me see, f of y equals y squared, right? And now y is a function of x, so the answer here is, so the derivative of f with respect to x is going to be the derivative of f with respect to y times the derivative of y with respect to x. And so the derivative of f with respect to y is going to be 2y and then dy dx. And that's as far as I can go if I don't know what y is. Okay, and let's try again. Let's see, if I want to take the derivative of sine of y of x with respect to x, that should be an x. Then what's the answer there? Well, you have to take the derivative of the sine, and you get cosine of y times dy dx. Okay, so derivative of cosine of y, derivative of sine y with respect to x is going to be cosine y dy dx. Okay, so with that in mind, let's go ahead and try this backwards. If I say find the antiderivative of 2y dy dx with respect to x, that's an integral with respect to x, what's the answer? Well, we already know whose derivative is 2y dy dx. It's y squared, right? So this integral of 2y dy dx with respect to x is going to be just y squared. And notice there's sort of a mnemonic device here that the dy dx's, these guys can cancel. Now that's not really mathematically too sound to do, but it's okay in this case. So this is really just the integral of 2y dy. Okay, and if you wanted to do a u substitution, you'd find out that's right. Okay, so let's try again. What's the integral of 1 over y dy dx with respect to x? Well, again, if you remember your mnemonic device, you should say that's the natural log of y. Okay? Okay. So now we've reviewed the chain rule just a little bit. Let's try a problem here. Let's start with this ODE. I want to solve y prime equals y. And look, what we're saying is that at every point t, y prime at t equals y of t. So that would mean that 1 over y times y prime has to be equal to 1. Unless y of t equals 0, right? In that case, something else has to happen. So we'll just keep this in mind. Okay, so let's just assume that y is never 0. There's no point t such that y of t equals 0. And then we could say that if y is a solution to the original ODE, then y has to satisfy this new ODE. All right, and well, let's take a look. I could integrate both sides of that differential equation. I'd end up with the integral of 1 over y, y prime, and on the right-hand side I'd have the integral of 1, and those are both with respect to t. And both those integrals I can do, right? The integral of 1 over y times y prime is going to be natural log absolute value y, and on the right side I'll get t, and let me just put a constant of integration over here. Okay? Why am I not putting a constant of integration on both sides? Well, I could certainly put one over here. I could put a plus d over here, but if I did that, then I could just subtract the plus d over to the other side, and I'd get a new constant, and it wouldn't make any difference. Okay. So look, now we can almost solve, right? We know that the natural log of y has to be t plus c, and we can solve that. So we know absolute value of y has to be e to the t plus a constant, and that's e to the t times e to the c. All right. And so that means that e to the c, e to the c is just an arbitrary constant, so we'll call that a times e to the t. Okay, so we're relabeling this as a. Relabel as a. There has to be a positive constant. Constant. Because e to any power is positive, and a can't be 0 because e to the c is not 0. It doesn't matter what c you choose. Okay. So now we know that absolute value of y is a e to the t, and that a has to be a positive non-zero number. Well, what's that mean? That means that if y is bigger than 0, then absolute value of y is just y, so you'd get y is a e to the t. And if y is less than 0, then absolute value of y is negative y, so y is negative a e to the t. Okay. So this guy is a new constant, and it's negative. So what we can say now is that y is going to be a times e to the t, and a is positive or negative. But non-zero. Okay, so what we did up here is we relabeled negative a. Well, we said, well, that's just another constant, and we'll call it a also. That's relabel as a. Okay. Okay, now what's the subtlety? Remember, when we did all of this, we just assumed, to do all this, we assumed that a was non-zero. Or we assumed y was non-zero. Note that y equals 0 is a solution to the original ODE, y prime equals y. Okay, it's called a trivial solution. It is, oops. And anytime you go through this process, you have to go and try to find the trivial solutions at the end. Okay, so what do we know now? Now we can say that y is a e to the t, where a is non-zero, or y is constantly 0. Okay, so what we can do is we can just say, well, we'll include the case that a equals 0 in this general solution, and we'll say that the general solution is y equals a e to the tth power. Okay, and that's it. So let's try to formalize this process that I went through just a little bit. Okay, so any first order differential equation can be written like this: dy dx equals, and then something over here. All this means is that there's something on the right hand side. It has y's and x's in it. If you can factor out that right hand side so that it is something involving g's, or something involving x's, okay, something with only x's, times something involving only y's then the differential equation is called separable, okay? And what we'll do is we'll proceed like last time. I'll divide everything involving the y's over to the left-hand side of the DE and say that if y was a solution to the original ODE, then y is going to be a solution to this ODE unless this denominator happens to be 0. And if this happens to be 0, then we might get a trivial solution. So we might get a trivial solution. All right, so what we'll do is we'll integrate both sides of the ODE to get something like this. So we'll integrate 1 over h of y dy dx, and we'll integrate g with respect to x. And we'll do the integration, and whatever we get, we'll have h, and that'll involve only y's on the left-hand side of the integral. And we'll get something on the right-hand side that depends on only x's. So we'll have something like this, stuff involving y's and then stuff involving x's on the right, and then we'll just have to solve for y. So that's the process that we're going to go through. That's called the process of separation of variables, and we'll do several examples in the next video.